Hey guys, welcome to today's lesson. I hope everyone is doing okay today. Um, how much snacks did you all eat already today? I know I probably ate a lot, but oh well, that's all we pretty much can do right now. But let's get started. So for today's lesson, we're going to look at scatter plots. And if you have your packet, you can go to page 293. That's where we're going to start. If not, you can look at it online. If you go to the website online, I'll post the link for it on my website if you don't have it. And if not, you can just take some notes. It's okay. Alright, so we talked about this a little bit before we left, and when we think about scattered plots, we know we have to have some specific data. So I'm going to go down here and I'm going to talk about the definition. So what is a scattered plot? A scattered plot is a graph of ordered pairs in a coordinate plane that represents the value of two variables. So we know we have to have an x variable and a y variable. So we have to have two sets of numbers. So we talk about numerical values, so numbers that we will plot on a graph. So let's go back up and see what else they want us to talk about. So it says when you have a data set involving two variables, the data is called a bivariate data. So bi meaning two, variate meaning variables, so that's where they get the term bivariate from. And data is just data. Like if I go running and they say I ran for 30 minutes and I did 2 miles. Well, in 60 minutes, I'm going to do 4 miles. So bivariate, the running time versus the miles. A scatter plot is a visual way to determine the association between the two variables. So like my example, my miles versus my minutes. So that's going to tell you, if you look at it on a data sheet or on a graph, it'll tell you. The relationship between two variables is called their association. So how do they relate to one another? Is it a positive relationship? Is it a negative relationship? Or is it no relationship at all? That's what that means. Alright, a positive association exists when as one variable increase, the other value increase. For example, the relationship between calories burned and the time spent exercising. So the more time I spend running on a treadmill, the more calories I should burn. That would be a positive association. Whereas a negative association exists when as one value increases, the other value decreases. So example, the relationship between the temperature outside and the heating costs. So the hotter it gets outside, the more money we spend in our electricity bill because we're running the air conditioning unit more. That makes sense? Alright, remember, if something does not make sense to you or you're kind of confused on something, just jot a question down and then you can send it to me via email, Instagram, Facebook, or you can have your parents, or you can text it to me. There is a no association when there is no clear pattern of increase or decrease between the two variables. So what that means is the values fluctuate, meaning that they all over the place. 1 minute they're up, 1 minute they're down, 1 minute they're stagnant, meaning like they're staying in the same situation for the same time. So it's kind of all over the place. So for example, the relationship between a person's shoe size and salary. So some people that have small feet might make a lot of money. Some people that have small feet might make a little bit of money. People that have big feet, they might make a lot of money. People that have big feet might not make a lot of money. So that's kind of all over the place. And we can look at the chart at the bottom right here. So let's look at this. So for instance, we have somebody that has a size 9 shoe here, and this person has a 9 shoe, and this person is 66 inches tall, and this person is 65 inches tall. Well, the people that have size 12 feet, they're almost as close to the person that has a size 9 foot. So What is the association between a person's shoe size and their height based on the data? Does this look like as their shoe sizes get bigger, their height increases, or as their height increases, their shoe size get bigger? What you think? So more than likely, the more a person grows, the bigger their feet is going to get. So let's look at this. This is just a table showing you, but let's look at it on a graph. So it says make a scatter plot of the data, then look to see whether the data shows any trends. So trends meaning is it a positive or negative or none at all. So if they were a 6, they're at a 61-ish. If they had a 7.5, they're at a 62. They were 8, they're at 64. The 9s, they're at 65 and 66. The 10 at a 68. Our 11, he's at a 68. And the person that was a 12 wears a 69 and a 71. So this looks like a positive trend because more than likely, every time that person grows, the feet grows as well. So you see how this is going in a positive direction from bottom to top. So bottom to top. So the point appears to have an upward trend. It appears that as the first value increases, so does the second value. So our answer would be as the shoe size increases, the height also tends to increase. This shows a positive association between shoe size and height. Alright, so going back over our vocabulary, we talked about what a scatter plot meant, and I gave you a brief definition of what bivariate meant, just including two variables. Alright, so let's look at this. So everyone should know how to graph their coordinates on the plane. Our x's come first and our y's come second. So for example, we have 5 and 3 for our A. So A is graphed at 5 and 3, both positive. -4, -2, we start at -4 on the x value, go to -2 on the y axis. We start with C, -1 on the x axis and 3 on the y axis. So -1 and 3. D is at 0 and -1. So we start at the origin and just go down to -1. And E, which is at 4, -4. So we go all the way to +4 and we go down to -4. So that was the example for that one. And it gives you an exact whereabouts to go. If you're confused, it just tell you where to go. So for number 1, it asks us point B. An example is in which quadrant. We always start with this quadrant and we call that quadrant 1 and we go this way. So this is 1, 2, 3, and 4. Again, that's quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that would be in quadrant 3. Alright, it says suppose both coordinates of a point are positive. Which coordinate is the point located? Well, all positive numbers are over here on the right and at the top. So we would say quadrant 1. Alright, it says without graphing, in which quadrant is -2 and 4? Well, we know negative numbers are on the left side and positive numbers will go at the top. So that would put us in quadrant 2. Alright, and if you look at the bottom right here, it shows you, if you forget, how to label your quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Alright, and you can answer part 4 on your own. I'll leave that one for you. When a point is on the axis, on the y-axis, like point D in the example, what do you know about the x-coordinate and what is the y-coordinate when a point is on the x-axis? Alright. Alright, so this one says to solve. When we solve them, we're looking for explanation, a direct answer. So it says the table shows the location of exhibit at a science museum. Use the coordinate plane at the table for the problems 5 and 6. So we know we're using this table for both problems 5 and 6. 5 wants us to graph each exhibit at the science museum as a point on the coordinate plane and label it with the first letter of the exhibit name. Alright, so we would have to find where our coordinates are. So flight is at 4, 2. So we go positive 4, positive 2, and we would label that with, I would just put an F for flight. Okay, and then you would do the same thing for the following 3. And then it says describe how you graph each exhibit. So if you want to go back all the way to the top and look at their explanation of what did they do. So for this point, they moved 5 up, 5 units right, and 3 units up. And so you would do the same thing for yours. So for mine, what I did with the flight, I moved 4 units to the right and 2 units up. So I would describe mine that way. Alright, it says give the coordinates of the points that are on the coordinate plane at your right. So you would have to write your coordinates here. So let's just take one. So I say point W. So I will locate point W, and that's at 0 because it's actually on the y-axis. So that would be 0 and positive 3. So 0, positive 3, and that will be the coordinates for W. So remember, coordinates are like our address. So if I ask for your address at your house, that's what coordinates are like. We can find the coordinates for that. Alright. And I think you guys got the gist of that. So let's look at the actual scatter plot. Alright. So it says the scatter plot represents data comparing the incomes of a company. So incomes of a company is on the side. So we know income is always measured in dollars. So it's on the side. And the employees and the number of years of experience they had. What trends do we notice? Well, looking at the graph, it looks like it's going positive. As the more years you spent there, the more money you kind of earn, right? So this appears to be a positive association between income and years because there's an upward trend. The income increases as the number of years increases. Alright, so that explains that. And I want you to work on 1, 2, and 3 and 4. And then when we move down, you're going to use this actual graph to do 5, 6, 7. 7 actually has its own graph. Yep. Okay. Alright, and remember, if you're not sure how to do the scatter plots, we can always go to IXL. And we can kind of look at this. So for example, it says Greenville has a zoo and an aquarium. This table shows how many people visited the zoo and how many people visited the aquarium each day last week. So this is zoo versus aquarium. So look at aquarium is our y value and zoo is our x value. And they want us to plot these variables on the graph. So when I'm at the zoo and there's 20 people at the zoo, there's 60 people at the aquarium. So I would plot 20 and 60. If I'm at the zoo and there's 40 people at the zoo, there's 75 people at the aquarium. And you would just do that until you've done each one of these and hit your enter button. So 40 and 75, 70 and 40, and then 100. Well, we have 80 and 25. Then we have 120. Oh, nobody wanted to go to the aquarium that day, huh? And 115. And then we have 90 and 20. Alright. And that's it. Alright, so that's all I have for you guys today on Scatterplot. Like I said, feel free to reach out to me by text, phone call, email, Instagram, Facebook, whatever you have. but just be safe most importantly. Bye now.